Hey there! So, in this lesson, we'll be talking about collecting and organizing data. Now, this is somewhat important for the various reasons I mentioned earlier, but what type of data is best to collect? Well, we have here primary data. Give me a second, let me just grab my pencil. Primary data is when you collect the data directly, when you're when you have the ability to do an experiment or conduct a survey and you get the responses directly. This is preferable, but not always available. Sometimes participants are put into situations and then you don't really interact with them or try to influence their opinion or anything. So you don't really interact with them much while they're in these situations or in these thought experiments. And you want to have their responses measured. So primary data is when you do the experiment or the survey right there personally. Now, what is secondary data? Well, it's data collected by other people or other experiments or other surveyors, because in truth, sometimes collecting data might be a bit difficult. For example, there are some situations that are uncommon. Let me just finish difficult. Some situations which are uncommon, such as health conditions. Like not everybody is gonna suffer from a specific disease or a specific ailment. In that case, you may want to collect data from around the world from people um, who have these specific conditions. And conduct a survey under or and conduct a survey under different circumstances. For instance, let's say a new drug comes out, but there's only so many people suffering from a specific disease. So when you're conducting these trials, well, they're very small, and there's not going to be a lot of people to participate in this trial. So sometimes it's better to collect data from other places, maybe other countries or other cities, and gather them as a whole. But the problem is you don't have control of the experiment or the survey. You have to read what the others the what how they were collected and what their other conclusions were. So that's the problem. You don't have much control over the surveying process or the question or the experiment in general. That's the biggest downfall for secondary data. And I think that the last past couple of years we saw a lot of this happening. And there might be errors, as I mentioned, there might be errors in the published data, secondary data, depending on how the data is gathered. And this is often seen when bad data has been introduced, and it sort of like affects the opinions and policies, and even the experiments of other surveyors or other people who are trying to analyze the data. So this is why your data has to be accurate and unbiased. And also, if there were any limitations to how the data was collected. So that's actually a big one. Um, like again, not everybody's in certain situations like health conditions. Not everybody has um, a heart murmur. So it's sort of difficult. So secondary data is probably the only way to gather information. Primary data should be your first choice, and secondary data should be it's somewhat unreliable. So example one, let's do some examples. This is simply just the scientific method. In short, it is a scientific method. Uh, but it says here, how does a practice affect the time to do a task? Design and perform an experiment to determine if the practice affects the time to climb a rock or rock climbing. So design an experiment, you set up a recording sheet for participants, trial number, and time to complete the trial. So basically, you have to record the data. So you got to design the experiment for that thing. There's a couple of things involved, but the main thing to do is to make sure when that the design of the experiment is unbiased. And like again, here isolate the participants to prevent them from watching other participants. Because the truth is, a lot of people like to copy each other's answers. So you're not going to get a true answer because they may be self-conscious about giving their own answer. So you have to isolate them to get their true response, opposed to them copying another person's response. Step two, recruit a sample of the population. So once you do the experiment, well, you want to make sure this is before the experiment. You want to give only enough information about the experiment not influence the results. If you tell them what the experiment is for, then maybe they might try to work harder or work less, depending on their biases. So you give enough information about the experiment, but not so much information as to influence the results of the experiments, because um, if this can affect them personally, then they might actually try harder or try less based on how much information you give them. So this is sort of a good general rule of things, to give enough information, just enough. Step three, you perform the experiment. This is when you start to perform the experiment. Monitoring the experiment and recording results is very important, especially to monitor to make sure the experiment is running smoothly and there's no biases or any errors, because there's always errors in experiments, but we can control a certain amount of them to a certain degree. So it's important to monitor the experiments. Once that's all done, everything's finished, you want to organize the data. And the best way to organize the data in general is to put it into a table, because a table can be converted to any graph and it can be easily analyzed. So you want to organize the data so the details can easily be read and analyzed, or at least easily read. The analyze part can come in the second part, which is step five, display the results using a graphical tool. So, well, the fact is, the reason we have graphs and charts and tables is because looking at a table is not the best way to interpret data. It's not, unless you're like an expert or great at numbers, it's very difficult to read the data and to interpret it. So we like to use things such as graphical tools, such as charts and tables, that gives you a basic interpretation that can be made at a quick glance. For instance, and when someone looks at your resume, if you're applying for a job and someone looks at your resume, they don't look at your resume like in details. Oftentimes, employers just have a quick glance of it. They look for specific keywords, and then that's it. They make their decision based on a couple seconds of viewing your resume. So you want to interpret a lot of results in graphical tools, because a picture can tell 1,000 words. And finally, you want to analyze the results. This is where you get to discuss. You try to be unbiased, but you try to discuss the results and the limitations of the experiment. It's important to discuss the limitations of the experiment, or if there are any biases, such that the results or the integrity of the paper would be valid. You want to discuss what patterns you might see and what it might suggest. You don't want to use words such as this does this or that does that, because the truth is, uh, it's just an experiment, and it's just one experiment, and it's a limited experiment. So you just want to discuss what the data might suggest, not what the data is, because you don't know definitely what the data is. You only know what it might be. So your language should be put in such a way that you're only suggesting or showing an indication, and at the end of it, you want to state that you probably need more experimentation to get a stronger conclusion in that sense. Again, what the result patterns might suggest, not what it is, but what it might suggest. Okay, so that lesson was pretty quick, and that's about it.